Hey, good evening, everyone. All right, so today we are going to continue our class project presentation. So I would like to invite Group 13, 柳文荣、赵可生、李明耀、陈大友 to prepare the slides and start the presentation. Hello, 柳文荣、赵可生. Is the group there? Is Group 13 there?
Hello, Professor.
Oh, so I made a misspelling. So that's Li Wenrong, right?
Yeah.
Okay. Liu Wenrong, that's true. Liu Wenrong. Yeah. I didn't make mistake. 赵可生、李明耀 and 陈大友.
Professor, could you see my screen?
Yes, very good.
Okay.
Please go ahead.
Okay.
Yeah, we'll consider the time, okay? 12 minutes. Maximally 13 minutes, okay?
Oh, yeah, we got it. Okay, so good evening, everyone. Tonight, our group will present you a smart analysis of bike sharing, which is also our work for the big data competition. What's a bike sharing system? It's a new form of traditional bikes rental based on sharing economy, and it becomes more and more popular as a major urban transportation. It serves almost everyone in need anytime, anywhere in the city. In the bike sharing system, every bike is installed with a sensor to record trips happen in detail, including the user's identity, time and location of borrow and return. In this project, we focus on the analysis of a bike sharing system in Washington, D.C. urban, called Capital Bike Share. We obtained the history trip data from the official website and generated the count of the bike rentals dataset to recognize the pattern of mobility in the city and solve the potential problem of bikes being overclustered. There are two datasets used in this project. Dataset 1 is the hourly count of rentals labeled with holiday, working day, and some weather information. We use this dataset to train a machine learning model to predict the amount of bikes. Another dataset is the history trip data of Capital Bike Sharing System from September 1st, 2020 to August 31st, 2021. We use this one to train another machine learning model called KNN to learn the spatial temporal pattern, which provides different strategy to avoid bikes overcrowding on certain spots. The first dataset is generated from this one based on an event labeling method. This is the overview of our project. Let me explain how it works. First, we choose a target date we want. The model inputs and processes the weather forecast data and labels if it's a working day or holiday according to the calendar. Then it aggregates the prediction of 24 hours from the random forest regressor. If the total amount is greater than the threshold we set, the KNN model will be invoked and do parking guiding for users or bikes dispatch for a company. Depends on the date. More in detail will be illustrated by my teammates.
First, we use multiple linear regression to predict the rented bike amount. Here, R-square equals to 0.2163, and the scatter plot indicates that this model needs to be improved. Then, in order to obtain a better fitting model, we fit the through regression on the training set with lambda chosen by cross-validation. The coefficient of apparent temperature shrinks to 0, but R-square is still only 0.215, which indicates that linear regression doesn't fit the amount and the other features well. And regression tree has many advantages. We fit a regression tree for the dataset and we draw the feature importance. The bar chart is the result after sorting the feature importance. Compared to linear regression, RMSE improved from 297 to 189. This shows that the regression tree has lower error. And gradient boosting gives a prediction model in the form of an ensemble of weak prediction models, which are typically decision trees. We applied grid search and cross-validation to two parameters, with the score matrix set to RMSE and the cross-validation for k equals to 5. For random forest, we applied two methods for tuning parameters. Random search and grid search. The random search first sets a range and a step, performs a random combination of parameters within the range, derives the training score by cross-validation, and then outputs the parameter combination with the best score. The grid search further traverses a small range of parameters and cross-validates them based on the results of the random search in order to derive the optimal parameters. According to the training results, the most important features for count are hour and temperature. Among all the features, hour has the greatest influence on the training, and its distribution pattern of the rented bike amount is the most obvious. The line chart and the table shows that the random forest performs better than other models.
In this part, we hope that through the spatial temporal analysis in the peak period of bike renting, the problem that the bike cannot be stored or borrowed can be solved through bike dispatch and parking guidance. We define the rented bike amount change in a parking set equals to the number of bikes returned in the site minus the number of bikes borrowed in the site. The daily rented bike amount will affect the rented bike amount change of each parking site. Whether it's a working day will affect the distribution of rented bike amount change. Take the data top 50 in total bike usage of working days and weekend respectively as a representative of the congested data. Accumulate the bike change of each hour in the site to get the cumulative change of each site. In order to visually display the time and place of the peak period, ArcGIS is used for visualization. First, locate the station on the map according to the latitude and longitude. Then, the cumulative amount of each station is presented hourly. This video shows the visualization results. The blue cross represents the station where bikes are returned in the peak period, and the red box represents the station where bags are borrowed in the peak period. From the visualization results, we say that in working days, the stations with parking peak and are gathered together. In these stations, the newly returned bags have no place for parking. The stations with renting peak are gathered together. In these stations, it's difficult for users to borrow bags. On weekends, the station with parking peaks are scattered. We can get the user of park the bags in the nearest site without congestion, which solves the problem of no place for parking and no place for renting bag. For working days, we use KNN model to divide the area into parking peak and renting peak. In our model, the geographical longitude and latitude of the station is used as the feature, and the cumulative change is used as the label. The blue area in the map represents the peak area for parking, and the red area represents the peak area for renting. According to the divided areas dispatch bags from blue area to red area, the RMC of our order is 0.2298 and the R square is 0.7886. We compare the partition results obtained by the KNN model with the original map. We were surprised to find that there are some important places in peak area, such as the White House and the US Capitol.
In part 4, we summarize the knowledge obtained from data analysis, and we will come up with a strategy for shoring back management, which will be explained with an example in this part. The main method we use to dig out some insights is data visualization. By drawing the line chart, we find that the relation between data and the daily related amount, people tend to use sharing bags for transportation on weekends. But it's less possible for them to use sharing bags to commute on working days. In the line chart of hourly rented bag amount, we find that the peak period of bag rental in working days is 8 o'clock and 18 o'clock, while in weekends, the peak of renting bags is from 13 o'clock to 15 o'clock. By drawing the points with different color on the map, we represent the congestion for parking and renting. From where we find that the spatial distribution for renting peak on working days is more concentrated than on weekends. From the box figure, we see that few people rent bags in cold weather. The bags rental increases with the rise of temperature, and it keeps stable when the temperature is higher than 20 degrees. Based on the machine learning models, we come up with a strategy for bag dispatch, which optimizes the distribution of sharing bag resource. Here, I will use an example to show how it works. We obtain the hourly weather forecast date of Washington, D.C. in 25th November, which is input into random forest model to predict the rented bag amount. Since the predicted value is higher than the threshold, we think that it's necessary to dispatch bags to avoid the terrible bag distribution. Then the bag should be dispatched from the blue area to the red area. The two areas are divided according to the historical trip records and the KNN model, which should be updated with the update of historical trip date. That's the end of our presentation. Thank you for your listening.
Okay, thank you for Wenlong's group, group 13. It's a very interesting analytics work. I think it's a nice job and also very well time control. Yeah, thank you very much. So then next, I would like to move on to the next group. Group 14, 陈子琪、陈子燕、王一倩、刘七龙. Yeah, please.
Okay. Can you hear me, Dr. Zhang?
Yes.
Okay.
Please go ahead, do your presentation.
Hello everyone. Our group topic is travel insurance forecast. Here's our content. My part is the introduction. Let's see the definition about travel insurance. It's available to cover medical expenses, trip cancellation, baggage losses, flight accident, and other international or domestic travel losses. Let's say uninsurance cases with nightly news attesting to acts of terrorism, international conflict, healthy outbreak, and even natural disaster. It seems that the risk is all too often a travel companion. If travelers require medical care while they are away from their home, their cost can be exorbitant with about of gastroenterologist potential costing the uninsured traveler $12,000 in Hong Kong or fracture ankle in Peru amounting to $24,000. In order to minimize the potential risk outcomes, travel insurance has now become a vital part of travel plans. So why we need to buy? Overseas travel insurance is not only a mandatory requirement to apply for visa in some developed countries in Europe and the United States, but has also become an important option for travelers to transfer the risk of traveling abroad. Travel insurance can afford financial security for the traveler against what can be very costly claims for medical and related travel expenses in the event of misadventure. Our research proposal is after collecting the data, we use EDA to filter out the type of data that have impact on the purchase of travel insurance, and then use the model to filter out the potential purchase of insurance and predict which condition have a high probability of purchasing insurance. Now I invite my groupmate to introduce the exploratory data analysis.
Okay, let me start out by putting what I think is a relatively light proposition on the table. And that's that what is the data description? When stripped down to its very essential, it's really quite simple. Now, why do I say that? Well, we think that before you can start doing data analysis, you need to familiarize yourself with the data. I like to call this get to know your data. The other thing that I think would come out of the discussion is the data source. We built this site to have their further consolidation. The data from the online website with the necessary items we need for statistical machine learning. This study provides the item of coherent data in the table. Next. Let's look at the significance of the data in several dimensions. Data contains demographic criteria such as age, occupation, education, income, housing size, health status, flight frequency, and travel frequency. One of the most powerful tools for doing so is make segmentation, which typically use data to group potential customers by demographical criteria to determine what types of customers will be most representative to a particular product or marketing message. For example, which characteristics makes people more likely to buy travel insurance? Furthermore, before integrating data analysis, remember to always check the frequencies of all variables, how categorical variables have been coded, the minimum and the maximum variables, and the number of missing observations. This is a good way to identify any outliers and potential mistakes in the data set. Okay, next, I will invite my groupmates to continue.
Okay, here shows us the variables of the data sets. All variables are here. So we go next page. here we come the features correlations. We use the 5K to analyze these features correlation and can have some information like if one is a college graduate, what employment type does he or she have, and annual income are highly correlated to his or her age. And if there one has traveled abroad is the most highly correlated to his or her annual income, which is very easy to imagine. Okay, next page. I will begin to introduce the relation between features and our targets. From these two graphs of age feature, we can see that people whose age is between 29 and 33 are more likely to buy an insurance. And people with the age of 35 are the least enthusiastic to buy an insurance. Then the employment feature, people who are self-employed are more likely to buy an insurance. Education feature, we can say this have a little influence to our target. Annual income feature, this box shows that people with high income are more likely to buy insurance. Family member feature, there is a trend that if you have more family member, you are more likely to buy insurance. Chronic disease, this also has little influence to our target. Frequently flyer feature, okay, as I imagined, if someone flies frequently, he or she will likely to buy an insurance. And the last, ever traveled abroad feature, this, if someone ever traveled abroad, he or she will much more likely to buy an insurance. Then I will pass to my group mate.
Okay. So based on the previous analysis, our next work is to use the data to train the model. Firstly, we divided the existing data set into the training set, the test set, and the verification set. Since the data set is not very large, we choose to allocate it according to the proportion of 80% and 20%. Since what we need to predict is whether users will buy the insurance, so project can be regarded as a classification problem. Also, most features in our data are categorical features, so we choose to try the decision tree, logistic regression, and ensemble models like random forest and gradient boost in this project. Regardless of the time and memory cost of training a model, ensemble models are often a better choice since they are likely to have a higher accuracy. So we first choose to train the gradient boost model. For the gradient boost model, various hyperparameters of the model will have a great impact on the accuracy of the model. So we need to adjust the hyperparameters of the model during the training. In our project, we use the grid search cross-validation provided by sklearn for hyperparameter adjustment. For the first training, we use all the features as predictors and got the following results. Well, based on our previous analysis, the impact of chronic disease on the target is not very obvious. Therefore, we conduct the second training and delay the chronic disease and got the results as follows. We can see that accuracy has increased significantly. This shows that our previous analysis is correct. We also tried logistic regression and random forest and the decision tree. So in general, gradient boost perform best, but it takes a lot of time and memory to adjust the hyperparameters, and the accuracy is not much higher than the decision tree. Therefore, when the data set is not very large, perhaps the decision tree is also a good choice. And we also do some further optimization. Based on the correlation metrics, we can see that the annual income is closely related to the employment type, but employment type is not closely related to the insurance. Therefore, we try to delay the employment type, but the model performed worse than before. And we also try to delay the graduate or not, which has a lower correlation with the insurance, and the model has a little improvement. And we finally do the same thing on the decision tree and also a little improvement.
Okay, in the last part, I give you some brief summary. Travel insurance is an important guarantee for the safe development of tourism. It should insist on people-oriented reform and innovation, actively promote the cooperation of travel insurance, and start to mobilize all positive factors to accelerate the healthy development of travel insurance. According to the principle of policy guidance, government promotion, market operation, and regulation management. Here's our references. That's our presentation over. Thanks for your attention.
Okay, thank you for group 14. It's very complete, nice work, and also very well time control. So next, let me invite group 15, Chai Yue-Yi, Tan Xueting, and Zhang Yating, Xu Lizhen. Yes. Group 15, please.
Can you watch my screen?
Yes, also I can hear you.
Yes,
Please
thank
go
you.
ahead.
Our topic is analysis and exploration of energy demand. Next, the content is mainly divided into the following 5 parts. Next. Part 1, background. Energy is inseparable from daily life with the continuous adjustment of the industrial structure. The energy consumption in cities is also constantly changing, and the energy consumption behavior of residents is gradually becoming personalized. Besides, energy consumption is highly related to economic and social development. Predicting the energy load can help the company and the government to rationally and dynamically regulate the supply in various regions of the city to achieve a low energy and high efficiency energy supply. Therefore, we choose the energy consumption dataset, analyze the energy consumption, and try to predict the energy demand to provide a certain databases for the city's energy supply. Next. The first goal of our analysis is to analyze the current status of energy demand. The second one is to forecast energy demand and provide databases for urban energy supply. The last one is to identify the models applicable to energy demand forecasting. Next.
Then I want to introduce our dataset. This dataset is from Cargo, which is a dataset about energy consumption, generation, prices, and weather recorded in every hour in Spain. This dataset is divided into energy and weather. The energy set contains information about the energy generation by different types of sources, such as fossil fuel and nuclear, prices, and the actual energy demand from 2015 to 2018. The weather dataset contains the description of weather conditions in 5 main cities. Main features shown as the following figures. Then, to achieve the data dimension reduction, we combine the energy data and weather data using the time attribute in energy and DTISO in weather. After that, we chose the Madrid as the city we focus because it is the capital of Spain and more representative in terms of energy consumption. Next, we drew a correlation heat map to observe whether there are some features that are not related to price and demand. From the heat map, we deleted the temp min, temp max, generation fossil hard coal because of multicollinearity, and removed rain 1 hour, rain 3 hours, and snow 3 hours because of the small correlation with price. For the default values, since they take up only a very few parts in the dataset, all the rows with default values were removed. The meaning of weather ID, weather man, and weather description are the same, so the latter two were removed. DTISO was also removed. The dataset is divided into training set and test set according to 8:2. The split is not random because the dataset is a time series. Except for LSTM, other models uses 3 attributes separated from time, which are month, day, and hour. All of them are transformed into float. For LSTM model, the time attribute is transformed into time step. All the data used in network are normalized. Then I want to introduce some basic analysis. Figure 4.1 shows that the energy demand reaches the maximum at the area from 24,000 to 32,000. Figure 4.2 shows that the trend of demand in the 4 years are very similar, which indicates that there is no major changes in the behavior patterns of people's life. Year 2017 had the lowest demand. With some search results, this might be because of a severe drought in Spain, which led to the decrease of activities related to water. Figure 4.3 are the box plots of energy demand and price. The left is the demand. It is clear that for demand, there is no outliers and energy demand has not changed significantly during 4 years. This might indicate that the development of Spain is slow. For price, it is obvious that there are large amounts of outliers, especially in 2017. Besides, the price went down from 2015 to 2016 and kept a slight increase from 2016 to 2018. This will lead to a bad forecast since outliers will severely influence the accuracy of regression. As a result, the prediction of price is cancelled.
Okay, next we make model predictions. Firstly, the random forest model, RF. And the reason we choose it in the first place is not only to use it to predict demand, but also to use it as a feature collector to collect out important variables for other models. So we can get this picture, which is the fitted plot comparing with the actual plot, of which the x is the predicted value and y is the actual value. And the square of R, MSE, and the MAE are shown in the PowerPoint. In terms of the importance of predictors, it can be found that hour is the most important feature, which an importance score of over 0.3, which means that time should have a strong influence on demand to some extent. Besides, generation hydro, pumped storage consumption, generation fossil oil, and generation fossil gas are also very important for demand prediction. Meanwhile, generation fossil coal-derived gas is the least important feature, which importance of 0. Okay, then the second model is ordinary least squares, OLS. Because OLS can't achieve autonomous deciding and feature selection, we use the result of random forest feature importance analysis and choose the time most important variables to predict. Let's look at the results. The square of R of OLS using tri-seed is 28%, which is good. According to the description analysis of OLS shown in the figure, it is obvious that there are statistically significant association among all these time features and demand, with all p-values less than 0.05. So these features can be used to predict demand. And in test state, the square of R, MSE, and MAE are shown in the PowerPoint. The chart is the fitted map of prediction and the actual values. Okay, now we use the spot vector regression SVR to predict the demand. Similarly, datasets used in OLS for trying and testing are also used in SVR. Finally, in test state, the square of R, MSE, and MAE are shown in the PowerPoint. And the fitted results comparing with the actual values is shown as is the figure. It is obvious the extreme values can't be well predicted, and SVR tends to predict the demand to be lower than the actual. Although the SVR can follow the trend of demand, it can't well capture the fluctuation pattern of demand. Okay, next.
The next method is CNN. Since TensorFlow is powerful, we directly use it to help us deal with all the mathematical and technical details. We processed the convolutional layer, which is multiple stacking, pooling layer, and fully connected layer on the input normalized features. After 10 iterations, which means the epoch is 10 and the size of each batch of data is 8, the test set accuracy rate reaches 81%, which is better than SVR. The test mean square error of the 10th iteration is 2.5 milli, which is slightly less than SVR, and the MAE is 5,000, which is much larger. From the right figure, it is apparent that predicted values are evenly distributed on either side of the true values. On balance, CNN's prediction is also poor. Next.
Well, in this part, we use the long short-term memory as well as LSTM model to analyze. After 20 epochs that the size of each batch of data is 50, we get the following model loss figure. Based on that, we can see that the training loss and the test loss in the LSTM model reduced to a lower level within 5 epochs. And after 5 epochs, both show a slight decline, which might be the reason for the fitted results of LSTM. According to the figure below, we make the comparison between the actual values and the test values. Also, we obtain the R square is 94%. The MAE is more than 300 and the RMSE is more than 400 in the test set. Obviously, the fitting effect of LSTM is great. That's the analysis using LSTM.
Then I want to make some comparisons. The SBR prediction is the worst among all the 5 models. The MAE of CNN is much worse than SBR, while others are slightly better. Take calculation cost and calculation accuracy into consideration. CNN's prediction is also poor. The difference in prediction accuracy between RF and OLS is not significant, but considering that the feature selection of OLS is based on the prediction results of RF, the prediction of RF is better than OLS. Obviously, LSTM performs best among all the models in all indicators. This may be because in addition to general features, LSTM can well capture the variation pattern between time and electricity demand and retain the factors that have a greater impact on electricity demand through iterative screening over time. Then I want to draw some conclusions. Firstly, there are clinical fluctuations in electricity demand. Also, since the demand distribution mainly lies in the area 24,000 to 32,000 and around 32,000 reach peak, the company should guarantee that the basic demand supply will be no less than 24,000 and the maximum supply should be at least 32,000. Secondly, it is apparent that the demand for electricity is not only related to the type of energy source, but is also influenced by time. Thirdly, weather features did not influence the energy demand in the RF, OLS, and SBR model. This may be because the weather data did not match the energy data. This may also be because only extreme weather and the meteorological and geological hazards associated with extreme weather can affect electricity supply. Fourthly, STM model can be used in energy demand prediction. RF can also be used to select features. Finally, I want to point out some limitations. We did not take the fact into account that different areas in the city have different needs for electricity, such as residential, commercial, and industrial areas. Besides, appropriate weather data with concrete weather descriptions and subsequent meteorological and geological hazards should also be taken into consideration to find out if there is really a relationship between weather and electricity supply. Thank you for your listening.
Okay, thank you for group 15. This is also a nice work. All right, next I would like to invite group 16, Wu Yao Hao, Wang Yanqi, Huan Ze, and Qian Chen, please.
Okay, can you watch our screen?
Yes, also I can hear your voice. Okay.
Okay. Let's begin.
Yeah, please go ahead.
Could you please play the PowerPoint? Okay. Hello everyone. Today we are going to share the topic of data analysis about Airbnb, and this is the outline of our presentation. Hope you guys enjoy our presentation. Next, please. Next page. In this part, I will introduce the background and methods of our analysis. Airbnb has become a giant in the short-term retail industry in the world in just 9 years and have strongly impacted the pattern of the traditional one-list industry. Airbnb launches its business to create value through the sharing economic business model and experience the explosive growth. Airbnb's business model helps owners take advantage of underutilized assets, The famous researchers has illustrated that the leading peer-to-peer accommodation share platform has more than 3 million listings and has hosted more than 200 million guests worldwide. Airbnb has changed the consumption patterns of travelers. Recent estimates indicated that for every 1% increase in the number of Airbnb lists, the total revenue of the Texas hotel market will decrease by 0.05%. Next, please. Next. Last one. Within a few years of its estimate in last page, please. The page 3. Next. Within last one. Within a few years of its established in 2009, Airbnb has become one of the most successful shared economy platforms. Airbnb had attracted 100 million hosts and guests worldwide within revenue of $100 million that year. The company developed its business model based on a compelling value position. Next, please. The dataset we use describes the listing activities and the metrics in New York City for 2019. We can find out more information about host geographical availability, necessary metrics in this dataset. And this dataset has lists 58,895 homes with 6 describing features in New York City. Next, please. This article provides user portraits for Airbnb, a smart community platform product. The related explorers why Airbnb is popular and put forward some suggestions for improvement. We mainly use tools including Python, Excel to perform the data processing, exploratory data analysis, and application of machine learning algorithms and some visualization of the city, New York City Airbnb 2019 dataset. Next, our group will detail the analysis.
Yeah, hello everyone. I'm Huang Zi, and I will present you some of our analysis. First topic is about the hosts of Airbnb houses. We first observe the number of the houses that the host has and draw some pictures to visualize it. And through the bar chart, we show some hosts owning the top 10 number of the houses. It turns out that the top 2 hosts actually take the dominant lead with more than 100 or even 300 houses, with the rest of the top 10 hosts owning only about 100 or less than 100. So the top 2 hosts may be pioneers of Airbnb hosts in New York, and they have their own business empire. The bubbles below are the names for these hosts. And for another thing, from the box plot in the middle, we see clearly that the top 2 hosts mentioned before end up being outliers, with other tens of thousands of hosts concentrating down below, near, or in the interval from 0 to 50, which shows a common situation for the New York Airbnb hosts. Next page, please. Next, we focus on the names for the houses. The idea comes from the intuition that the names matter a lot for guests when they make the choice. And we may want to find some attractive points that the house is reflected by their names and figure out if there are some common text characteristics, or put it in another way, is there any tricks in naming your houses if you or a host hoping to attract more guests? We do this by conducting a visualization of the names of all these Airbnb houses using word cloud. We can easily notice that there are some adjectives and descriptive kind of words for these houses and are used in a rather high frequency, and these words pop up to potentially show some features that may be attractive to guests. For example, the cozy, the park, or the central, and so on. Next page, please. Next, we may naturally have some interest in the correlation between different variables or predictors, such as price, the number of reviews according to our common sense, because number of reviews often represents the popularity. So we calculated the correlation matrix and visualized it. Before that, we created a dummy variable for the room type, which contains 3 types. Unfortunately, it turns out that there is no strong and meaningful correlation in this case, but there is indeed 2 variables have the coefficient of negative 0.95. The 2 variables are nothing but simply 2 of the 3 room types. So it can be explained that by the fact that these 2 room types have close number and they account for the major room types of all houses. With the left 1 type have very few of them. Next page, please. Finally, we had a try to predict the house price with some other predictors using some simple machine learning methods. The models we proposed are linear regression, lasso regression, and the random forest. The result is that random forest performed much better than the other 2 with the calculated R-square and the root mean square error. Of course, there may be more models can be tried, such as polynomial regression and some other tree methods and some deep learning methods that we have covered in this class. Okay, that's all for my part, and my partner Tian Chen will introduce more on our analysis.
Hello, I'm Qian Chen. I will introduce the Gini graphic characteristics of New York Airbnb listings. The following picture describes the number of houses in the 5 administrative regions of New York. It can be clearly seen from the picture that the rooms are millions described in the 2 regions of Manhattan and Brooklyn. This description is very reasonable. Manhattan is the most densely populated area in the 5 administrative regions of New York, where Brooklyn is the most popular area in New York. Next page. Next page. Yeah, we can say the number of the rooms in different price ranges. The clear say that most of the rooms cost between $15 and $100. Next page. The next page shows the number of the room in minimum nights. Most customers will choose Airbnb rooms as a short-term stay option, and most will only 5 for 1 day or 2 days. Next page. We know the populative of the room can be determined by the number of the comments, but such comments are not only positive but also negative. We can say that most of the rooms have only a few or dozens of comments, but some rooms even have hundreds of comments. Those rooms are very popular. Next page. In the data set of the New York Airbnb, there are 3 types of the rooms: entire home apartment types, private room types, and shared room types. We can easily say that the number of the room with shared room table is very small. Next page. My team member will bring some conclusions of our project, please.
Okay, finally, as you make a conclusion and suggestion for Airbnb's data analysis, we mainly use the tools including Python and Excel to perform data processing and exploratory data analysis application of machine learning algorithms and some visualization on the New York City Airbnb 2019 dataset. First, some special hosts found to own their business empire on the NYC Airbnb market, and they seem to make very good use of the smart housing that's likely to make a large fortune. Second, some characteristics on the house name and geographical distribution of NYC Airbnb houses are found, showing how smart housing is going on in this area. Third, no strong and meaningful association are found between this variable according to correlation analysis. Fourth, this machine learning model try to predict the house price, and random forest shows a relatively good prediction. The last, some basic information about the Airbnb houses through brief exploratory data analysis. Based on the Airbnb's analyzed results, we give the following suggestion based on the characteristic of regional distribution. It is recommended that when Airbnb use paid advertising, the traffic structure of the advertise should be as close as possible to the area where Airbnb users are concentrated, such as placing more advertise in the Manhattan and Brooklyn. Because modern people value having their own independent space, only a small number of people choose to share a room. It is necessary to advertise the intra-family and private room type of rooms in the publicity. Platforms, operators, and the homestay owner must provide more products to meet users' personalism, the accommodation experience, and personalism leisure and vacation series. The platform should support special areas, tax, and the special room type. Many users live in a homestay to meet the experience that standard accommodation products cannot satisfy, such as gathering with friends, stay away from the world, and being close to the nature, as well as functional needs that are rurally provided by standard accommodation, such as cooking. And at this stage, for such user needs, we must gradually move closer to the personalism needs. Okay, this is all of my presentation. Thank you for listening.
Okay, thank you for Johan's group, group 16. It's also a pretty complete work. Nice job. Next, I would like to invite group 17, Xu Chao and Zhang Xinyu, Fan Shuwei, Wang Siwei, please.
不知道他在弄，他在弄。要重新怎么拍重新？
I guess you guys met some technical problem. Can you be solved quickly, or if you need more time, we can switch. That the next group go first and you go next. Hello? Any response? Oh, okay.
Hi.
Hi. Yeah, I guess you said like wait a moment, right? It's not wait a month. It's weird. I saw myself in the screen. Great. I can see this. I can see your screen, but I cannot hear your voice. I cannot hear your voice. Did you use the Zoom share function? Share screen function? You can use the Zoom share screen function. Right. That's the share. Yeah, you click the button.
Sorry, sir. Could you please turn to the next group because we encounter with some technical problem.
Okay, so I would like to move to the group 18. Yang Yongwei, Chen Xu, Wu Xiaoliang, Fan Yuehan, Liu Zixuan. Yeah, please. I guess the previous group, you need to stop sharing your screen. Yeah. I cannot hear the voice. Xiaoliang, are you talking to us?
Hello.
Yes, I can hear you now. Please go ahead, your presentation.
Hello everyone. Today we want to introduce our group work with a topic in spatial temporal data analysis and the related factors study of PM 2.5 concentration in Beijing. Next. Our research framework includes 4 parts. The first is the background. Secondly, we conduct a spatial temporal analysis and build the correlation model. Then we make a prediction based on LSTM. Finally, we give some outlook and suggestions. Next. Let's talking about the background. Due to geographical and economic condition, Beijing is often affected by air quality issues, and PM 2.5 is an important indicator of air quality. It is defined as particulates that can be suspended in the air, which have equivalent diameters of less than 2.5 microns. It has a great impact on the health of people's respiratory system. So we choose this topic. Next page. We want to introduce a process model that's associated with the production and accumulation of PM45. It is called ETT process, including the direct emission through industrial process, natural process, or people's daily life, the transformation from other air pollutants, and the transmission through atmosphere, human activities, and biological process. In fact, it's not only for PM 2.5, but also a general process for many other air pollutants. Next. We choose hourly PM.5 data from 6 stations located in inner city, ordinary urban areas, and suburban areas respectively to do a spatial temporal analysis. Next. Considering that human activities and natural factors may be related to the concentration of PM2.5, we draw a 24-hour mean curve based on the data of each station in 2016. We found that the trend of concentrations in each station are basically the same. Overall, the concentration of PM.5 is relatively lower during the day and higher at night. At the same time, we observed the curve of Dingling station in the suburbs is at the bottom. Combine our experience, people's cooking process, daily periodical transportation, light conditions, and daily temperature variations may be related to the concentration of PM.5, but these factors are hybrid. So we need to do analysis on the different time scales to eliminate some factors. Now, let Fan Yuhan to introduce the rest content. Fan Yuhan.
Hello, Fan Yuhan.
Hello.
Hello, can you hear me?
Yes, finally.
Okay, let's continue. As we know, due to the work and vacation, people's life and industrial production have a weekly cycle. From the figure, we can see that concentration trends at the 6 stations are basically the same, with the lower concentrations on Monday and Tuesday and higher concentrations from Wednesday to Saturday. It can be also seen from the figure that the 2 stations located in the core urban area detected higher concentrations than other suburban stations. At the same time, the concentration had a certain hysteresis compared to the psycho-human activity, which reveals that the concentration of PM 2.5 may be related to the transformation process. Next, we observe the changes in the monthly average. The lowest concentration in February and August and the highest concentration in December. We all know that during the festival in Spring Festival in February, industrial production will be suspended and the urban population will decrease. And August is the most rainy and hottest period of the year. We know that the supply and heating start time in Beijing in 2016 will be mid-November. It's reasonable to believe that the concentration is influenced by climate factors and human activity at the same time. We also drew an average curve on a seasonal scale. Among them, comparing the results of autumn and summer, we can infer that there is indeed a certain connection between climatic factors and PM2.5 concentration. In order to further explore the connection between PM2.5 concentration and climatic factors and human activities, our team members conducted more in-depth and detailed research.
And then we analyze the influencing factors of PM2.5. We take the Olympic Sports Center, for example. Next. And these are data we analyze. Next. First, we proceed the data, deleted the missing values, and then standardize the data. Next. We made a box diagram to briefly analyze the influence of all factors, and then we divided the influencing factors into industry factors and climate factors, and adopt a correlation analysis. Correlation analysis includes person correlation analysis, Sparman correlation analysis, and a candle correlation analysis. Next. In order to explore which correlation analysis method to use, we first conducted a normality test. Data normal distribution is one of the preconditions of person correlation analysis. Firstly, we tested the normality of PM2.5 and other 10 factors. It can be seen from the PPT that they all do not have normality. Then, considering that Sparman correlation analysis is calculated based on a rank of random variables rather than its original value, and the requirements for data conditions are not very strict. So we choose Sparman rank correlation. Next. We classify sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone into industry influencing factors to explore their correlation with PM2.5. According to the figure, we can see that there is a significant positive correlation between PM2.5 and the sulfur dioxide, nitrogen dioxide, and the carbon monoxide. And there is a significant negative correlation between PM2.5 and ozone. Next. And we take temperature, pressure, dew point temperature, precipitation, wind direction, and wind speed as environmental factors for correlation analysis. It can be seen from the figure that there is a significant negative correlation between PM2.5 and the temperature, pressure, precipitation, wind speed, and the wind direction. And there is a significant positive correlation between PM2.5 and the dew point temperature. So we can see from the two figures that the dew point temperature and carbon monoxide has the greatest impact on the concentration of PM2.5. Next.
According to the above preliminary analysis, the stepwise regression was further used to analyze each factor. The choice of independent variables is completed by automatic process. Stepwise regression is performed by looking at the statistical values. Next.
The results of stepwise regression analysis are shown in the table. The relationship between PM2.5 and other variables can be seen as shown in the formula. Aspirate is 0.718. That means sulfur dioxide, temperature, and so on factors may explain why 71.8% of PM2.5 changes. Next. In the second part, the relevant factors affecting PM2.5 are analyzed, and the concentration of PM2.5 is predicted below. Considering the periodicity of PM2.5 concentration, non-short-term network is selected for prediction. Next. Firstly, the data is processed and the missing values are deleted, and the wind direction is one hot coded, and the original time of the dataset is processed to establish the time index. Then the dataset is standardized, and finally the train data and the test data are divided. Next. LSTM structure and specific parameters are shown in the picture. In the drop-down oil, the drop-off rate is set to 0.2 to avoid overfitting. And the noise rate was the default value, and the loss is the mean absolute error. Next. Mean absolute error change during combination. After 50 iterations, the loss of both the final train state and test state was reduced from 60 to approximately 17. Considering that the result is not computer convergent, further iteration can be carried out. Next. And this is
the sound becomes very weird.
The results are shown in the figure. Blue represents the original value, green is the train value, and yellow is the predict value. Next.
Okay. By observing the monthly average data of various locations from 2030 to 2070, we know that the PM 2.5 levels in various areas of Beijing have shown decreased changes. The PM 2.5 concentration in Beijing in 2070 was 51, which is far from China's before PM 2.5 concentration. But the national standard, which is the WHO minimum standard of 35, is still far away. Next page. Compared with correlation analysis, we recommend that the government further strengthens regulation. So China is the first to propose the concept of new smart city at the end of 2015. China's also smart city market has maintained a growth of more than 30%. In recent years. So Beijing, as the capital of China, definitely need the repeat development of the smart city to create a smart life for the people. So first, we should control the generation of precursor substance. The government should promote the use of clean energy, enrich the means of clean heating in winter, and promote green travel. And next, we should improve the monitoring of the precursor substance and effective manual intervention. Beijing needs to enhance the wisdom of the city through the 5G network-based fixed sensors and mobile sensors, real-time monitoring of the concentration of air polluted inside the city, compared with the manual regulation of the atmosphere, humidity, the effective regulation of pollutants is realized. For example, fog canal car and so on. So last, we should strengthen the early warning mechanism as the elements have the great impact on PM 2.5. Beijing can strengthen the early warning of the PM 2.5 based on weather forecasts and use smart city broadcast system to effectively warn citizens. So above all is our group presentation.
Okay, thank you very much for group 18. Now I would like to ask whether group 17 is ready now.
I think there's something wrong with the last computer, so we change one. I'm ready now. Wow.
Okay, great. Please go ahead.
Yeah.
The topic of our research is the congestion of intersections based on an aggregate measure of stopping distance and waiting times at intersections. The presentation will be divided into 4 parts: background, datasets, PCA, and clustering, and the algorithm. Firstly, I will introduce the background of the problem. Smart transportation is an important part of a smart city. In fact, the concept of smart transportation is not far away from our daily lives. We have all experienced being stuck at intersections. To solve the problem, we hope to build a model to predict the intersection congestions. This not only improve our lives, but also is a basis for the digital transformation of traffic management. As a basic practice, we select a data set about traffic congestion at the intersection in 4 cities. The data set has including the manufacturers about the motor vehicle and the intersections and the time and the distance from the first stop. A total of 856,225 records are included. In this practice, we are going to predict the time and the distance, so we choose the features about time and distance as the target feature. All these features are different types and has different distribution. In the next few pages of PPT, we will process them to make it more convenient for a next operation. Firstly, we can notice that there is something strange. There is something strange in the table. And the intersection has 2,559 values. However, we can still notice that for the longitude and the longitude, there have more than 4,000 values. It is because that in the different cities, some intersections have the same ID. So we combine the city with the intersection ID. We know that latitude and longitude hold the information about the intersection ID and the cities. On one hand, geograph information may hold more hidden information such as the distance. On the other hand, for the decision tree, we need to split to get the information while using the intersection ID and the city. So we choose to use the latitude and longitude instead of the intersection ID. When it comes to the city features as a follow graph, we can see that the Philadelphia has the most records. And if we focus on the distribution while discard the number of records, we can find that the Boston and Chicago have similar distribution, and Atlanta and Philadelphia have the similar distribution. So we believe that the city feature may have significant contribution to the model, so we should keep the feature. Can be found in the dataset that the street has various names such as the road, the street, avenue, and so on. We believe that the differences of this name may have contain some important information. So we divided this street into 4 categories and recorded them. According to these categories, the distribution of the recorded are as this. Vehicles have different headings, which affect the traffic constructions. We can record a total of 8 headings, but compared with classifying them with 0 to 7, I think the relationship between the heading can be better perceived with the value of sign. So we concluded the sign value of all the 8 headings. So the distribution are as is. Here are the distributions of the data recorded according to the categories. Similar with the heading, we believe that the hour also has the same continual information. So, but however, there is a problem. When we introduce the sign value, we can express the continuity, but also we cause some trouble. It's because since for the 0 and 12 hours, they have the same sign, but actually they are not continued. So we should both keep the sign value and the ordinary date. When it comes to the months, the distribution are just like this. We can see that the data lie on the January and the May are really little. So we propose to merge May to June and the January to December.
In this data set, there are 6 features that can be used to evaluate the state of traffic congestion. The large number of evaluation features makes mapping and analysis more difficult. For example, component analysis can help us reduce dimension by calculating the percentage of information that's presented by the first 2 components found by PCA. We found that it can present 92% of the whole data. According to the figure, we have found that target distributed on weekends and weekdays are similar between 2 pairs of cities, Atlanta and Philadelphia, Boston and Chicago. To get more insight of the data, we try to divide the traffic status into some categories according to the congestion. We use the K-clustering algorithm to do this. According to the figure, we can choose number of clusters as 4 using allowable method. And according to the clusters, we can get these distributions.
So now let me introduce in the algorithm part. So because of the large amount of data and complex relationships between various features and the limited equipment we have, we chose LightDBM algorithm to build the prediction model. So LightDBM is a gradient boosting framework that uses tree-based learning algorithms. As you can see, there are many memorable features such as fast training speed, lower memory usage, and so on. So better train and test accuracy, we divide 30% of the record into the training set and the rest into the test set. So considering the convergence speed of LightDBM algorithm and its disadvantage of overfitting, we divide the training process into 2 steps. So for the first steps, we select a parameter using for training. So firstly, we set a hyperparameter, which is a series of parameters using for constructing the model. And in the second step, we will choose one of the parameters to train the model. So the we'll also use the validation data for evaluating the model using root mean square error. So finally, we will choose the parameter with the best result, as you can see on the right-hand side. So after we have selected the best parameters, we'll train the model. It will iterate for 10,000 times, and the model will check overfitting for every 250 rounds, and it will stop if overfitting happens. So since LightDBM based on decision tree, we can measure the importance of each feature with information gain after each split. So from the result, we can see there are some more information behind the latitude and the longitude. So the future of hour takes the second important place. So what also interests us is that feature of city only has little contribution to this model. So one reasonable guess is that the distance between these cities is far. Thus, the combination of latitude and longitude has already contained the information of the city. So finally, we will verify our model using the test set, and R-square and RMSE are both used to evaluate the result. So as you can see, the RMSE is around 37.1, and the interpretability of R is shown as R2 around 79%.
According to the previous pages, we find the most important features are longitude and latitude. We wonder if the importance ranking obtained from our model is due to the huge difference in traffic conditions between cities. So we select one city to analyze again. The result is as that from this, we know that the importance ranking has little to do with the cities. Thus, we guess that the congestion situation may be mainly related to the intersection. So we delete the geographic information, and here is the result. As we expected, the most important feature is the intersection ID. We guess it is possible that the cause of congestion is unreasonable and outdated urban planning. And that is all. Thank you for your listening.
Okay, thank you very much. That's a interesting finding, analytical work, and also interesting topic. Where did you find the data set? I forgot to catch your point.
Pardon, please.
Where did you get the data points? The data set.
It's from Cargo. It's a data set about traffic congestion of some intersection in 40 cities in USA.
Oh, okay. Okay, thank you.
Thank you.
All right, so next, let's invite group 19. Tai Zikwan, Ma Qiyuan, and Yinka Yi.
Good evening, Dr. Zhang and everyone. First of all, thank you for your time to hear our presentation tonight. We have a team of 3, and our project is about predicting energy consumption. I'll quickly go through the background for this project. My teammates will follow up with our analysis, the prediction methods, and our key findings. First slide. So why predicting energy consumption, and why in the UK? Given the global energy crisis, there's an immediate urgency to reach the most efficient use of energy and to help with this clean energy transition and become a smart city. Given UK is one of the worst hit by this global crisis, we have chosen to analyze and predict energy consumption in the UK. Just this year, 14 British energy suppliers have gone bust. The shortage has pushed wholesale prices 5 times higher than a year ago. Hence, we propose an energy consumption prediction model using machine learning and neural network, which can potentially help to save energy consumption by optimization. Next slide. We have studied a few research papers done in the past predicting energy consumption. In some, their findings shows that weather, especially temperature, plays a key part in predicting energy consumption. And also, deep machine learning using neural network is one of the best methods to do this prediction. As an extension to their research, we have added new variables such as energy plan and consumer types on top of weather to do the prediction. Next slide, methodology. We collected data from the Kaggle and the London data store that contains the data for a sample of over 5,000 London households. We look at the time period between 2011 and 2014. In this project, we've applied several machine learning algorithms, including lasso, ridge, k-nearest neighbors, forward selection, best subset selection, and neural networks such as long short-term memory. I'll pass on to Anthony to go through the next part of our presentation.
So let's explore our data set. So our data set consists of multiple files, and basically they are energy consumption for both half-hourly and daily, weather information for both half-hourly and daily, household information, and finally the tariff price. So here's some observation. In general, also in London use more electricity from November to February, that is winter season, and use less from May to September, that is summer season. And here we can see that there is a negative correlation between energy consumption and the temperature. And similarly, energy consumption has a negative correlation with dew point temperature and UV index. However, there is a positive correlation with the cloud cover and humidity. So basically, this heat map is summarize what I have mentioned earlier. So I won't go to detail, but I want to mention the energy does not have a significant relationship to the wind bearing and pressure. And now I'll pass the time to Leo for further analysis.
So thank you, Anthony. So here are more observations. So we also compared the energy consumption of households of different financial abilities. We found richer households used more electricity and poor households used less. Among the sample households, around 20% were subject to a dynamic time of use energy prices in 2013. Every day, these customers would receive the energy prices of the next day, which may be high, normal, or low at different times. Normal customers were subject to a flat rate. The observation is that households in the dynamic plan used less electricity. We performed further investigation. For each month and each household, we take the average consumption when the high price point is active and another average for the low price point. Then we make box plots of average consumptions comparing dynamic rate households to normal rate households. We discovered dynamic rate households used noticeably less electricity when it is more expensive, but used roughly the same energy when electricity is cheaper when compared to households under a flat rate. For the next part, we try to use different models to predict the average energy consumption. For the pre-processing, the main point is that we performed standardization for each predictor, and we split the train and test data by a 7:3 ratio. There are 12 possible predictors which are related to the weather. Some of them are correlated with each other, which is not good. So for linear regression, we used different tuning methods to overcome multicollinearity. This project performed energy consumption prediction on a daily and half-hourly basis, but we will mainly focus on daily prediction for this presentation. The daily dataset consists of around 800 observations, while the half-hourly dataset consists of around 38,000 observations. Mean square error was used to compare the performance of models. First, we used forward selection. We fit a linear regression with individual predictors and added the one with the smallest MSE into a selected list, which was initially empty. We looped the process of fitting individual unselected predictors plus the selected ones into linear regression and adding the unused predictor into a list if we were able to further minimize the MSE. At last, 8 predictors were selected and the MSE was 0.693. Then we used the best subset selection. We fit all possible subsets of predictors into linear regression and pick the best model with the lowest MSE. The best MSE was lower, but it was also very time consuming. Next, we use bridge regression. It is, next, we use bridge regression. It is a model tuning method on linear regression, which trains the coefficients of predictors to reduce model complexity. The MSE was similar to the forward selection. Next, we use lasso regression. It is similar to ridge, but lasso can shrink the coefficients to 0. At last, 2 coefficients were shrunk to 0, but the MSE was still roughly the same. We also used another model, which is KNN. We searched for the K nearest neighbors and took the average Ys of the neighbors. We used all predictors and assumed uniform weight. The optimal number of neighbors was 121, and the MSE was 0.467, which is slightly higher than the best subset model. Now I will pass the time to Anthony to talk about the LSTM model.
So our team has also conducted the LSTM, that is long-short-term memory. This is a type of recurrent neural network. So for our LSTM model, we separate the data into train set and test set with the ratio of 7:3. And then we slice the data for every 60 time step, that is every 60 days, and with lag 1, that is lag of 1 day. And then we stack the data to create a 3-dimensional array before fitting to our LSTM model. So to improve the accuracy of the model, and to reduce the multicollinearity, we try to incorporate LSTM with principal component analysis. Here we iterate LSTM with different principal components. From the chart below, we can see that the MSE is pretty fluctuate, and there is no significant improvement in MSE after dimension reduction. And the MSE could reach to 0.45. Here is the predicted value versus actual value for daily consumption. We can see that in general, it could follow the trend. So as mentioned earlier, our dataset consists of both daily data and half-hourly data. So here, instead of using daily dataset to train our LSTM, we try to use half-hourly data, and that is about 68 times of the original one. So here we use the same technique, that is iterate LSTM with principal component analysis. So here we can see that when the components dimension is reduced, the MSE is worsened. So for this scenario, all features should be included in our model, as the MSE is the minimal at the very beginning. And our MSE has improved about 100 times. This is the predicted value versus actual value for daily consumption. We can see that the prediction for the energy consumption could follow the pattern, follow the trend and the pattern with some peaks and drops. So here is our summary. Below is a table of our MSE for daily prediction and half-hourly prediction of energy consumption. Here we can see that the best subset selection model has the best result for daily data, but it is the most time-consuming and computational intensive because it's considered all combination of our predictors. And for LSTM model, it worked well in both daily and half-hourly energy consumption prediction. This is because LSTM is designed for sequence of data, and this is best for our scenario. And in addition, we can see that the amount of training data is heavily influenced our accuracy of the model. We can see that our MSE for the half-hourly prediction is about 100 to 150 times of the daily prediction. Now I'll pass the time to Joyce for the coming slides.
So what are the challenges in our research? If we have more time, we would like to collect more recent data points. For example, in the past 2 years, more people who work from home can hugely affect the energy consumption pattern at home. Another challenge was the selection of relevant variables. New variables, such as the increasing use of computer power and robots, are new variables that could be considered. So modeling future trends, incorporating these new factors could help to improve the accuracy of the predictions. So next slide. As to the further work, we would like to do further research using deep reinforcement learning, which is another kind of machine learning. Instead of making assumptions about which variables we use, reinforcement learning agent learns energy consumption patterns by directly interacting with the environment. Repeated interactions through trial and error. Eventually, within milliseconds, it will learn to autonomously respond to changes in the home environment and optimize the use of energy resource. In that way, we can fulfill the energy needs at the lowest possible price with the most up-to-date climate information. Next slide. In conclusion, through this research, we have gained an insight into the importance of which fundamental features are important in predicting energy consumption. Most important of all, machine learning, especially neural network, can help to optimize energy consumption, to alleviate the global energy crisis, to reduce the environment impact to the world, and eventually help to build a smart city. I'll stop here. Thank you so much for your time, and please let us know if you have any questions.
Okay, thank you very much. It's a nice work, very insightful look into your results. I guess you guys think quite deeply about the results and the capability of those methods. Yeah, so I think that's nice. Right, next I would like to invite group 20, Yu Zhenyuan.
I'm here.
Yeah, this is your
Already.
solo. Okay, very nice. All right, please go ahead.
Let me start. Let's start. Okay. My topic is the visualization and analysis of Hong Kong air. Let me is there some wrong in my computer. Hong Kong air quality data based on DCAE is a new technique I will use. The rapid development of society is often accompanied by the deterioration of the living environment, especially the air quality. It is very important for us to know more about the condition changing of the air quality in order to future consider the time series feature of air quality. We use an improved DCAE-based emotion reduction visualization method in this project to see the different distribution of the time series patterns. Here is the steps of my project. First, download the air quality data of each station from the official website of Hong Kong and fill out the station and the years with more complete data for analysis. And then, is the data claim fill in the weekend values use interpolation. And then the forming new data set is processed by the DCAE method, which will encode the data and reduce the data demotion preliminarily. Several demotion reduction methods like PCA, TSNE, and UMAP are used to realize 2D projection visualization. And the last, analysis and inference based on visualization result. And here is the steps I draw it as the figure, just like the text. And here is also the same things. And then I want to talk about the algorithm involved in the project. First, I want to briefly introduce the CAE. The convolutional autoencoder is kind of neural network, and both the encoder and decoder of CAE are CNN networks. Convolutional network of the encoder learns to encode the input into a set of signals, and then the decoder CNN tries to reconstruct the input from the autoencoder. Among them, CNN works as a general feature extractor to learn how to best capture input features. With the addition of the convolutional layer, the special size information passed to the next layer is decreasing, but in the outcome encounter, the size and the depth of the reconstructed data should be the same as the input data, meaning that the decoder should adjust the data size and convolution to reconstruct the original data structure. And then I want to introduce the algorithm we really use the DCAE network. Here the figure represents its structure, and I want to briefly introduce it. In order to detect, explore, and interpret outline patterns and repeated patterns in large time series data, improved DCAE integrating demotion reduction method is proposed. And similar to CAE, the DCAE is also a kind of unsupervised method. However, DCAE has fewer parameters than the traditional CAE, which will reduce the computing burden and save the training time. And the number of network layers is the main difference. In order to extract deep future and encode the data into small demotions, we use total of 17 layers to realize the DCAE process. This function is defined by the MSE between input and output. The input and output is supposed to be the same, After encoding and decoding processes, the encoded result can be regarded as the projected latent variables which contain the whole information of the input date. And it is demonstrated that DCA structure is consist of 5 parts totally: the input part, the encode part, the compressed representation part, the coding part, and the output part. Each data group is regarded as a time series pattern and is processed by the designed DCA network. The input part comes from the preliminary process of date. And there are 6 layers in the encode part, which will extract the deep feature hidden in the input data group. After the 6th layer in the encode part, the results are put into the third part to form the encoded representation, and the dense result will be used to make future visualization. The first part is the decoding part. This is the reconstruction process, and the parameters in this part correspond to the network parameters in encode part. Finally, the final data format is restored to the same as the input data format in the output part. The size of the input shape and the output shape is decided by the specific data object and the field size, number of corners, etc. The improved DCA method can help us to find the perfect encoded result of the time series pattern. However, the dimension is still too high for visualization. In the encoding process, we cannot make the dimension too small, because the smaller the dimension of the coding result, the larger the MSE of the reconstruction result obtained by the encoding process, and a lot of important information will be ignored in the data compression process in order to realize the final visualization of the distribution of different time series patterns. Classical dimensional reduction methods are used to obtain the 2D projection of the input data. We will use the just like PCA, TSNE, and UMAP. The next slide. This is the error quality data. The error quality data of 10 different areas of Hong Kong is used. The 10 areas distribute evenly in Hong Kong. So it is possible to avoid insufficient comparison caused by selecting only some partial data. The 10 areas of Hong Kong contain the North, the Tap Mo, the Tuen Mo, the Southern, the Mong Kong, and some other areas. And then the downloaded error quality data for each area has 7 different variables. The data is collected from 2009, 2019, and the sampling frequency is 1 sampling per hour. It's designed by the sampling machine. And I want to talk about something about the disclaimer. As the data download from the website, we have to check it before using it to verify our method. The data at certain moments are missing for some reasons. For example, in the central area, the data of fine suspended particles at 7 on July 8, 2009 is missing. The distribution error will increase if the history date is used directly. So the averaging method is used to fill in the date at the moment. So we get a complete data set. Then the filled complete data are normalized. We do it normalized, and the result are future put into the proposed improved DCAE. integrating dimension reduction method. And the detail of the everything the data in shown is the data of TAPMO. And we will initial the DCAE structure before we do the experiments. And I want to briefly give you an overall value of how the data shape transform. Firstly, it's to 24R and 7 R is reference how many days the data sets have, and we transfer it become R 24/7, and we use the DCAE to flatten it. We just it is also R, and it's because R 60. You can see in the dense layer it is 60, and then we use PCA, UMAP, and TSNE. It becomes R2. Then we can visualization it. We can produce a 2D projection. And here's the results. The data is collected. We take Monday to Saturday, represent different days, and the PC result, TS result, and UMAP result are shown. Will be shown in the figures. In the PCA-based method, the purple dot represents the select days. For example, the first picture, the purple dots represents Monday, and the Tuesday, Wednesday, Thursday. In the UMAP method, the dot is dark green, and in the TSNE method, the dot will be dark green. And I will show the figure sequentially. And this is the TSNE, and this is the UMAP. And we also do to visualization it in months value, PCA, TSNE, UMAP, and the season value, PCA, TSNE, and UMAP. And we can do some analysis from the pictures. We can conclude to some rules. Rule 1, in figures, the distribution position of air quality data in the 2D projection are related to the air quality, and the better the air quality, the farther to the right side. And rule 2, January and December have the most serious air pollution problems, where August and September have the best air quality. Rule 3, the third season usually have the best air quality, and the positions of data in the 2D projection are closely related to the air quality. Rule 4, on the 2D projection results of the same method, air quality data in different regions show different distribution patterns, but the second and third quarters still maintain a similar distribution pattern, and the first and the fourth quarter maintain another similar pattern. Combine the actual situation and the above-mentioned data analysis results, we try to reasonably explain the air quality distribution. The purple reasons for the distribution are as follows. Reason 1, TAPMO, Chunwan, and Taichung close to the sea, which will be affected by the sea breeze,
I guess you
especially
need
in
to pay
summer.
attention to the time.
Okay, and the reason two is Hong Kong is raining in summer. Harmful substance in the air are easy to be attached. And the reason three, in summer, Hong Kong have a long period of direct sunlight, which can combine with harmful substance in the air to purify the air. Yeah, that's all. Thank you. Here is the data source. Thank you for
Okay,
watching.
thank you, Zhen Yuan. Okay. Next, let me invite group 21, Li Nan, Zhao Yuqi, Zhang Zhao, and Zhen Hao, please.
Good evening, this is Nan. Our topic is tour and travels customer trend prediction. Our presentation consists of 4 parts. In the beginning, I will talk about the background of the project, including the reason we chose this topic and the research status of this problem. I will also make an introduction regarding the dataset. Secondly, we also perform exploratory data analysis on dataset to acquire the relationship between the features and target. Then we build a model and optimize it. And finally, we draw some conclusions and suggestions to help the company. I will start with the background of this project. A large number of studies have shown that a company's customer churn rate is negatively correlated with corporate profit growth, and the cost of maintaining an old customer is much lower than the cost of acquiring and attracting a new customer. Research on customer churn rate has a long history. Scholars have been investigating this area since the early 1990s. At first, they used the methods of management and economics to solve the problem. Later, scholars began to use traditional statistical methods and regression analysis methods. That means quantitative analysis is gradually applied to solve this problem. In recent years, scholars began to use various programming algorithms for research, such as artificial neural networks, decision trees, support vector machine. Now I'm going to introduce this dataset. This dataset contains 6 features and 1 target. We have 2 numerical features and 4 objects.
Hello, this is Zhao. I'm going to introduce the second part. First, sorry, next slide. Hello. We draw the distribution of features for the target, where blue means the target value of 0 indicates customer doesn't change, and the yellow means 1 indicates customer change. From the histogram above, we can get some information and insights. The younger customer group seems more vulnerable to loss than the older group. The change of the former is almost twice of the latter. The main customer group of the travel company is low and middle income persons, but middle income customers seem to be more loyal. In recent years, fewer and fewer customers choose the company services again, whether or not the customer syncs their account to social media, or whether the customer booked a hotel through company's services does not seem to have an impact on the target value. In addition, as shown below, we want to calculate the correlation between each feature. Since correlation works only on numerical types, we need to encode all category code 1 into numbers. Then, we draw the heat map diagram of the pairwise correlation of each column. And we extract the correlation ranking between each feature and the target value. It can be seen from this table. Annual income class, frequent flyer and booked hotel or not, have a positive correlation with the target value. Through the above, we find out features related to the target value and will further explore and draw conclusions. This is my part.
Hello, Professor, can you hear me?
Yeah, please.
Okay, the third part is trend prediction. Before the prediction, we need to pre-process the data so that the data can be successfully put into using the model. Firstly, we built 4 pipelines. The pipeline 1 deals with unknown values by using simple imputer with the most frequent strategy. Then these pipelines will use one hot encoder, ordinary encoder, and standard scalar to encode and normalize the categories features. The advantage of using the pipeline is that the pipeline encapsulates the above data processing steps, which can easily make the parameter set be reused on new data sets, such as the test set. Then we split the data into training data and test data. Let's begin to evaluate and select the model. We select 8 classification models for comparison and draw the bar chart of the accuracy of each model. Accuracy refers to the ratio of the number of samples correctly classified by the classifier to the total number of samples for a given test data set. The 2 models that perform best are gradient boosting classifier and random forest classifier. In addition, we also draw the ROC curve of each model. AUC refers to the area under the ROC curve. The closer it is to 1, the better the model performs, as shown in this ROC curve figure. Among the 8 classification models, except that the AUC of Gaussian MB and Burnham MB models is lower than 0.9, the other 6 models performed quite well, especially the AUC of gradient boosting classifier and random forest classifier is highest 0.97 and 0.95. Based on the performance of these 2 models with the most potential, we select the 2 models for further exploration. From the classification reports of random forest classifier and gradient boosting classifier, we can see that these 2 classification models perform well on notch-churn, which is class 0. However, our goal is to predict churn customers, and in the classification of this goal, these 2 classifiers are not good enough. This is because of the class imbalance. The problem of class imbalance means that the target value, the total number of one class of data significantly exceeds that of another class of data. In our target value, the proportion of value 0 is more than 3 times that of value 1. So this is the reason that classifier perform not good on customer churn. To solve the problem of class imbalance, we will use SMTE, synthetic minority oversampling technique, to generate synthetic samples. SMOTE is an oversampling method which can create synthetic samples from minority classes. After using SMOTE to generate composite samples, the target value distribution in the training set is compared with that can be seen on the right. So we rerun the gradient boosting model using the training set of 2 examples. From the classification report, we can see that the precision of customer churn has decreased, but the recall and F1 score has improved. This is reasonable because precision is sometimes contradictory to recall. When the model wants to cover more samples, it will be easier to make mistakes. In this case, it may get lower precision and higher recall. As can be seen from the formula on the right, F1 score is comprehensive indicator of precision and recall. When F1 score is higher, the result is more ideal. The F1 score of our prediction for the minority class was successfully improved to 0.92 after example.
Hello everyone, let me show you the last part of our group presentation conclusion. We draw this diagram to integrate the model, from which we can get some conclusions. Age 27 to 28 and churn are in positive correlation, which means that younger age people tend to churn. Frequent flight and churn are both in negative and positive correlation. The positive value is higher than the negative value. It may mean that people who travel often also book for the time being and have to cancel it. Middle income persons and churn are in negative correlation. Low income persons and high income persons and churn are in both positive and negative correlation. People whose number of times services opted during recent years is 1 and churn are in both positive and negative correlation. On the other hand, 2, 5, and 6 and churn are in positive correlation. People who book the hotel and churn are in negative correlation. It means that booking the hotel may be a deterrent for churn. As a result, to prevent churn, especially the company should take care of young people's preference and can launch appropriate tourism services for young people and high-income people. For frequent flying customers, preferential packages of air tickets and other services can be provided, and more competitive lounge or hotel reservation prices can be set to attract more customers to book through the company. For customers who choose the company services twice or more, some preferential policies can be given to attract customers and prevent customer churn. Thank you for listening.
Okay, thank you very much for group 21. Now we are going to the last group, group 22. That's invite Wang Renke, Zhu Chongjing, and Tianjin Wen. I guess you guys need to first stop sharing and another group can share. Okay. Group 21, Li Nan, Zhao Yuqi, Zhang Zhao, and Zheng Hao. Is delayed or? Hello?
Hello, Dr. Zhang. Shall we go? Okay.
The previous group needs to stop sharing. Okay. Yes, I guess you guys can start sharing now. The previous group has stopped sharing. Okay, 5G users. Very nice.
Hello, Dr. Zhang. Hello, everyone. Today, we are delighted to introduce you our topic that the prediction of 5G users. Our presentation consists of 3 parts. First, background, second, data analysis, last, future guidance. Now let's turn to the first part. With the development of information technology, recent years have seen the boom of 5G. The massive connectivity and high-speed transmission capabilities of 5G networks are powerful support for smart city construction. We can see that China is a leader in the 5G communication era. Competition among operators for 5G user resources has become increasingly fierce. This is why operators need to identify potential 5G users in time. So that's our topic background, but where are our data from? The data are obtained from the Cargo platform, which is a data set on whether operators' customers are switching to 5G users. There are 60 variables in this data set. The dependent variable is whether to switch to a 5G user with a value of 0 or 1. The independent variable has a total of 59 variables, including user attributes like age, gender, also about user behavior attributes like call days, app active days, and operator attributes like whether 5G base station is covered. The following are our aims. We will analyze which factors have
has a great positive effect on the conversion of ordinary users into 5G users through predictive models. We can find the best algorithm to predict whether ordinary user will switch to the 5G user. For operators, data mining based on customer behavior will help operators better promote 5G at the product, terminal service and network levels, and develop service such as 5G user customer identification. Such operators can optimize their 5G base station city options. Then my teammates and I will introduce the part of data analysis. For this data experiment, we use Weka as our data analysis platform. The whole process data analysis will be divided into 3 parts: the data pre-processing, algorithm experiment, and result analysis. We selected 6,000 training sample data and 1,668 testing data with a total of 60 variables. Some of the variable types did not correlate with whether the user was a 5G user, so we removed them, and after initial processing, 24 variables remained, and we imported these 24 variables and the 6,000 instances into Weka for further data pre-processing. Since some variables of the nominal type are defaulted to numeric by Weka, we first need to use a filter to convert the variable type. Here are the specific steps. Select the data and then apply. Through visualization, we can see that out of the 6,000 samples, only 80 of the sample data are classified as 5G users. A series imbalancing in sample classifications that would lead to any algorithm meaningless. Therefore, we used the smart oversampling algorithm to automatically populate some of the sample data with the classification of 1. After oversampling, the number of samples in category 1 increased to 3,280, and the total sample size is 9,200. Okay, so then my teammate Chuanjing will introduce you the next part.
After the data pre-processing, we started the algorithm experiments with logistic regression firstly. In the classifier, we choose the logistic regression with 10 times cross-validation algorithm to train the logistic regression model. The algorithm automatically divides our sample into 10 equal parts, using 9 of them to train the model and the remaining 1 to validate the model, and so on 10 times. In this way, the accuracy of the model can be improved. In this training model, we can see 86.8% of instances were correctly classified with an AUC value of 0.94, which seems to be a decent model. From the model output, we can see the influence coefficients of these factors above. We visualize the ranking of these coefficients, and we can see that the city-5G ratio, service type, and turn type have a greater influence on whether the user is 5G or not. We then validate the accuracy of the model with new instances. Through this supplied test set, we set out our test data. And let's look at the results of this model. As you can see from the first image, 65% of the data was correctly classified with an AUC value of 0.63. The accuracy is at least over 50%. By comparing the test accuracy, we found that there is some gap between the actual test accuracy and the accuracy of the training model. It is probably because the number of our features is too large. There will be some overfitting problems in the training model. And we then experimented with the same data using the Bayes network algorithms. We found that 98.7% of the data was correctly classified with an AUC value of 0.9, which seems better than logistic regression. And we can see the IOC curve. Of course, we need to test the model to see if she is really that good. However, the accuracy of this model of the test data was only 60.9%. But we can't just look at the accuracy. We find that the AOC value was 0.72, which is higher than that of the logistic regression model. And finally, we have experimented with the data using the J40 algorithm, and we can see that 96.2% of the data was correctly classified, and the ROC curve also seems to be perfect. And from this decision tree, we can see that the total fee is the root node with city 5G ratio and its home 5G cover as subnodes, and city level and its work 5G cover. These two are under the city 5G ratio node. This is a plain text form of the tree, and we can see how the tree structure goes more clearly. From the structure, we can see that the total fee, the city 5G ratio, is home 5G cover. These attributes have more important influence on whether a person is a 5G user or not. And then we still need to test the model. We can see 62.6% of the data was correctly classified, and the AOC value is 0.65. In this graph, we can see a comparison of the accuracy of the J48 training model and the accuracy of the test. Then I will give the floor to my teammates Jingwen to look at some furthermore comparisons about the algorithms.
Finally, let's compare the accuracy of three algorithms. Firstly, we look at the accuracy of training model. We can see that Bayes network model outperforms J14.8 and logistic regression in terms of precision, recall, and AUC values. Then we can look at the outcome of the model testing of these three algorithms. Although the recall value of Bayes network model is a bit lower than that of J14.8 and logistic regression, its precision and AUC values are still higher than theirs. So we still think that Bayes network algorithm is the best choice among these three algorithms. From the above data analysis, we can see that three algorithms mentioned before are more feasible to predict 5G users. Among them, the Bayes network-based 5G users prediction model has the highest accuracy. In the section, the importance of each characteristic variables is ranked under the above prediction model. Based on the ranking results, we then propose future guidance for 5G at the national, social, and operator level. We found that the relevant factors such as total fee, CT 5G ratio, CT level, and its 5G based cover are important factors that affect whether users can be converted into 5G users. However, user attribute characteristics have a relatively low degree influence on the conversion of 5G users. It can be seen that for operators, the ability of subscribe to become 5G users is largely dependent on the operator's infrastructure and the type of network package supported. In terms of fee, in order to promote the conversion of existing users into 5G users, operator can adopt a portable number transfer policy and increase promotional activities to lower the package fee, reducing customer concerns due to the high 5G fee and to some extent, reducing the loss of users. At the same time, customize different package for different users, increasing the correlation between users' attributes and the packages so that users can choose package according to their needs. The state can increase the financial subsidies for operators, thus easing the financial pressure on operators for 5G construction. In terms of 5G base cover, operators need to increase 5G investment, accelerate the construction of 5G base station, increase the density of 5G base station, promote the construction and application of 5G networks. The state should implement the construction of 5G base station in the 14th five-year plan, achieving comprehensive urban and rural coverage. In terms of cities, start with pilot penetrate in major cities, increase the number of 5G mobile phone terminal connections, then ensure that 5G commercial service are available in all cities above the prefecture level nationwide. Finally, it is gradually promoted in countries, districts, and tends to promote the construction of smart city infrastructure. That's all we have for this presentation. Thank you.
Okay, thank you for the last group. Interesting study. All right, so I guess let's take a short break. Let's come back at 9:20. Then we will start the review of the final examination, okay?
各有
Okay, good evening, everyone. So we're going to have the review of our final examination. Others, could you please mute yourself? Yeah, so basically the final exam design is very clear. We are going to have majorly two parts in the examination question paper. So the first part will be multiple choice questions. It will be totally 10 of them. So this multiple choices question actually means you just need to select one single correct answer out of the 4. Okay, so it's not selecting multiple choices. The multiple choices questions means selecting single correct answer. Okay, so each of the question were with 4 credits and totally 40. And besides the 10 multiple choices questions, there will be 6 written questions and will be total 60 credits. So these 6 written questions include a mix of some simple calculations and concept understanding. Okay, so these simple calculations refers to some calculation examples of some of the algorithms we discussed in the lecture notes. So you just need to follow the procedure. So the examination will be 2 hours in open book. You need to bring your class notes. And I know that there will be a portion of our classmates who will attend this final exam online. So the online exam will happen simultaneously with the physical exam, but you guys just need to log on to the Canvas and download the question paper. Okay. So, but if I grade the online exam solutions, if I find that there are some highly similar answers, no matter you are doing correct or incorrect, if I find out that it's extremely like a plagiarism, then there will be 0 mark for both of the sides, okay, or 3 sides, and that simply means the failure of this course. So please do individual examination, okay. Cheating is not allowed. All right. So next, let's go through the lecture notes one by one, and I will introduce the scope that you need to study for each of the lecture. Let me see. For lecture 1, let me see. Wait. Yeah, I guess you guys don't need to look lecture 1. My question does not come from lecture 1. So let's start from lecture 2. Yes, you can write. You can write whatever notes on your class notes. Okay. It's open book. So lecture 1, you guys can skip, and let's do some lecture 2, process engineering and systems engineering. So those examples you can skip. Basically, these lecture notes, we focus on the concepts. So what is the process engineering? And so these IDEF methodologies, especially IDEF 3, you guys need to pay a little bit attention and see how those figures are prepared and what are components are included in these flow charts, and so kind of. And these systems modeling and concepts, this PDE and black box models you guys can skip. But black box model from data, and you start from here, and process models, and this observational analysis, and what is actually the process engineering do, like to make to be process model and from S model to B model, I guess. Yeah. No, it's as is model needs to be transformed into a to be model. Okay, so this is basically the process engineering. Let me see. This part is important. The computational analysis. The most important thing is the organizing non-cyclic graph and the topological sorting algorithm. The process you guys need to pay attention to. Okay. I guess that's it. The other slides you guys can skip. So lecture 3. So I would like to repeat again. So if your guys' English are good enough, then you will understand multiple choices just means selecting one single answer out of the pool of candidates, okay? So multiple choices means 选择题 and typically 单选题, okay? And for the lecture 3, lecture 3 we talk about what? Clustering analysis. Yeah, lecture 3, all slides are important. Lecture 3 is important, okay? Lecture 3 is important. All slides are important. So you guys need to spend more time in lecture 3. And lecture 4. Lecture 4, we talk about what? We talk about classification and regression, I remember. You start with classification. Lecture 4 is very important, as important as lecture 3, especially the decision tree methods, okay? Focus on the decision tree methods. And k-nearest neighbor, neural network, and support vector machines. Oh, naive Bayes, right. The naive Bayes is also important. How to use naive Bayes. These three are very important. I skip it, but you guys need to. Yeah, naive Bayes calculations is also important. Okay, naive Bayes classifier. So I have hand calculation examples. Bayesian belief networks, you guys no need to pay attention to. Lecture 5. Lecture 5 is also very important. It's referred to regression. So linear regression and regression trees, SVM regression. And the most important part is the artificial neural network component, okay? The artificial neural network component, the gradient descent, and also backpropagation process. So lecture 5 is very important. Okay, lecture 6 is an important conceptual part. So it's more like concept introduction. So you guys need to go through those concepts. It is also important, lecture 6. Lecture 7, you guys can skip. Okay, the Win application, we have some tests, but it's more focused on lecture 8. Okay, so lecture 8 is important. Lecture 8. Okay, so how we model the wind speed distribution and how we compute the power from the wind speed energy. Okay, and yeah, basically the aerodynamics model, not this one. Yes, this one. This one is also okay. Yeah, but basically the cubic of wind is the issue. And the others you guys can just have a glance. Okay, the remaining example you guys just have a glance. The beginning pages are. Let me see. Before page 20, okay, in lecture 8, from page 1 to page 20, they're important. Lecture 9, we will not test it. Lecture 10, we will not test that, okay? 9 and 10, we are not testing, okay? Half of the lecture 8, we will test. All right, that's basically all. Okay, a very quick and very precise scope of preparing the final. All right, any questions and comments so far? If no, then we can end up here today. And I would like to thank you all for your efforts in this semester, and good luck in your final exams. And thank you for working with me smoothly to make this course finish successfully. And also thank you for your efforts in the class projects. There are many very nice presentations, and I got a lot. Okay. Yeah, so a video of this lesson will be released tomorrow. I know some of you guys cannot attend class this night, so yeah. Yeah, wish you guys a nice winter break. I bet some of you cannot go back home, and some of you might choose go back home, but difficult to come back at the spring semester or just the second half of semester. So I wish your travels safe and smooth, everything go well. Okay. Someone asked me about the presentation score. I bet pretty late. Probably after I grade in your final, then together with your class project presentation score posted. But I should say, based on so far the scores, I already graded, but I didn't post it in the Canvas. But I guess everyone did quite well. So we don't have pool grades. Usually class project presentation won't differentiate much. Okay, but please pay attention to your project report, because that report I will understand things better. Yeah, some of especially some of you didn't tell the complete story. I don't know whether Zheng Yuan is here, but he did a solo. That's quite nice. He tried some very new algorithms for forecasting the Hong Kong air quality. But you use convolutional network with these numerical data. How you are going to organize your data as a tensor, you need to describe it quite well. You're missing this part in your presentation. Yeah, and the reasons of using PCA and TSNE to do the dimension reduction in the dense layer after the dense layer, and that could also needs to have. You can also use a fully connecting network to do the dimension reduction, right? So some of things you did something fancy, but why it needs to be fancy, you need to justify, basically. But anyway, I like your idea quite well. You are just a single man and did this project in this level is very, difficult to me. As you say, quite capable. Okay, and others, I just use Zheng Yuan's because he did presentation late. Okay, I can remember more about his presentation, but some of your presentation earlier, in 1 week earlier, there are also similar problems. You need to justify why you did that and tell me what is the finding based on your results. Okay, rather than just report me the accuracy, you need to tell me the findings or the knowledge after analyzing that results. Okay, so that's the different thing we do with just machine learning guys. Okay, machine learning guys, they focus on algorithms. They focus on general problems. They pursue higher accuracy without any reasoning. But we are more like a domain focused. We need to focusing on the knowledge discovery. Okay. All right, so that's all for today. Yeah, so I guess if you guys have no questions, then we disjoin here. Yeah, basically, one student asked me, do group members get the same score? Usually, the group will have the same score, unless some group members privately report me that some of your group mates are free riders. Or in a presentation, I can see someone who was very unfamiliar with the contents to be presented, and I have done the degrading. Okay, I'm a fair person, so yeah, I observe clearly. Right, so even you are sitting at the front of a computer, but from your voice, the way of presentation, I feel like zero practice at all. And then that could be a problem. Okay, you will be slightly different, but you will not receive very bad score though, but you will be different than your group members. Yeah. Okay, thank you very much. Yeah, have a nice night. See you guys. All right, bye-bye. Good night, bye-bye.